everyone. This is an introduction to cyclic groups. A group is said to be cyclic, meaning it's kind of a cycle, if the order of the group is the same as the order of at least one element of the group. So we're going to answer these questions. We're going to construct a Cayley table for our group G, for an example, 2, 4, 6, and 8, under the binary operation of multiplication modulo 10. And we're going to show that it's a group, write down the order of the group, calculate the order of each element of the group, and then hence prove that the group is cyclic. So the first thing we're going to do is construct a Cayley table, and that means right here you're just going to write multiplication modulo 10, like that. And then write your group numbers here, 2, 4, 6, 8, and 2, 4, 6, 8. And then under modulo 10, we're going to multiply and get our answer. So 2 times 2 is 4. 2 times 4 is 8. 2 times 6 is 12. And if you subtract 10 from that, you get 2. So that's how you do that, because that would be your remainder. And 2 times 8 is 16. Subtract 10 and you get 6. All right. And you keep going. So we get 8, 6, 4, 2. These are just going to repeat. 2, 4, 6, 8. And then the last one is 6, 2, 8, and 4. So that's our Cayley table. And now we want to show that it's a group. So we have to show that it's closed. Well, the table is closed because no new elements appear. So the only elements that appeared were the same elements given here. So it is closed. Now the identity element is going to be the one that gives you back to the original number. So for example, for the identity element, 2 times 6 gives you 2. 4 times 6 gives you 4. 6 times 6 gives you 6. And 8 times 8 times 6 gives you 8. So our identity element is 6, because that gives you back to the original number. So we can say our 6 is the identity element. Now, what else do we have to show? 6 occurs once in every row and once in every column. Hence, every element has an inverse. Since 6 occurs in every row, in every column, it has they have an inverse. For example, 8 star 2 equals 6. So 8 and 2 are inverses. But all we have to do is say that every element has an inverse. All right. Multiplication is automatically associative. So we write associative. So hence, G multiplication modulo 10 is a group. All right. now we want to write down the order of each group, of the group, and then calculate the order of each element of the group. So let's do that. I'm going to go ahead and write this out again. So this is 2, 4, 6, 8. 2, 4, 6, 8. And we got 4, 8, 2, 6, 8, 6, 4, 2, 2, 4, 6, 8. And you see that's the identity that right there. 6, because you get back to the original for this column, this row here. And then finally we have 6, 2, 8, 4. All right, so the group, the order of the group is 4, because there's 4 elements. This is 4 elements. That means order of the group is 4. Now C, we want to write the order of each element. So basically what the order of each element is when you get back to the identity. So we're going to do for C, we knew 2 star 2 star 2 star 2 equals 6. And you can look at the table I rewrote here. This was X mod 10. All right, so that means the order of the element of 2 is 4, because that's 2 to the 4th power equals 6. Because you want to get your identity element here. Now for 4, we get 4 star 4 equals 6. So the order of 4 is 2. 6, we've got 6 equals 6. So the order of 6 to the 1st power equals 6. So the order of 6 is 1. And 8, we're going to have, let's see what I'm going to use here. 8 star 8 star 8 star 8 equals 6. So the order of element 8 gives you 6. These all give you identity is 4. So when you're looking at the order, you're looking at this number. So order is 4. For this one, it's 2. For this one, it's 1. For this one, it is 4. All right. The order of element 2 and element 8, so these two, 2 and 8, is the same as the order of the group, which is 4. Hence, that means the group is cyclic. Okay. Now, we're going to talk about the generator of the group. So let's do that real quick. The element 2 is called the generator of the group, because it can generate all the elements of the group. For example, 2 to the 1st power is 2, 2 to the 2nd power is 4, and 2 cubed equals 8, and 2 to the 4th equals 6. Also, the 8 is the generator of the group. So that's element 8 is also generator of the group because 8 to the first power, 8 to the second, 8 cubed, and 8 to the fourth generate all the elements of the group. So this would be 8, 4, 2, and 6. And it's good to note that 8, the element 8, and element 2 are inverses of each other. That's good to note for that. So that's a big note for that. All right. The next video is going to be on some theorems that you need to know for your IB exam. And that's it. Thank you. Have a nice day. Bye-bye.